Okay, so the next program in chapter 5 is kinetic energy, or kinetic energy. All right, in physics, an object that is in motion is said to have kinetic energy. The following formula can be used to determine a moving object's kinetic energy. Ke is equal to half mv squared. So this is v squared. I just didn't know what to type for squared, so I just typed in squared. I didn't know exactly how to put the 2 above it. The variables in the formula are as follows. Ke is the kinetic energy, m is the object mass in kilograms, and v is the object velocity in meters per second. Write a method named kinetic energy that accepts an object's mass in kilograms and velocity in meters per second as argument. The method should return the amount of kinetic energy that the object has. Demonstrate the method by calling it in the program that asks the user to enter values for mass and velocity. Okay, so basically we've been given a formula to calculate the kinetic energy. It's half mv squared. We had to write a method which is going to receive the object mass. Okay, it's going to accept the object mass in kilograms and the velocity in meters per second as argument. And the method is going to basically calculate the kinetic energy and return it. So the method is going to return the amount of kinetic energy that the object has. And we had to demonstrate the method in main basically by calling the method and allowing the user to type in the mass and velocity. Okay, so let's go ahead and start. So I'll go ahead and create the class. I'll call this kinetic energy. And then I'll create the main method. Okay, so let's see. So we know we are going to create a method. Okay, so it says write a method named kinetic energy that accepts the object mass in kilograms. Okay, so we know we're going to create a method. So let's go ahead and define that method. We know that the method is going to accept in some arguments and it's going to return something. So we know some details about the method. We know the name of the method. So let's go ahead and write that method or define that method. Now, in the previous programs in chapter 5, I always mentioned that some people define or create their methods under the main method, which is fine. It's still going to work. I mean, it's going to work as long as you. When you define the method, it's available. It's available to this class. You can go ahead and call it in main, even though it's below main, and it's still going to work. But I'm going to define mine above main. It still works as long as you define it. You define it, it's available in this class. So it's fine. I'm just going to define mine above the main bit because I like doing that, for the most part. But sometimes I also define it below. It depends. But for this program, I'm going to define it above. Okay, so I'm going to create a method. I'm going to create a public static method. Public because the method is available to code outside this class, and static because the method belongs to this class. All right, so now I need to define the return value. Now over here, the method, it says the method should return the amount of kinetic energy that the object has. Now the kinetic energy can be a double value like let's say 23.5, or let's say 85.2. So I'm going to define the return value as a double then. And I know the method is called kinetic energy because it says write a method named kinetic energy. So I'm going to define the method name as kinetic energy. And Alright, so now we know that the method is going to accept some arguments because over here it says write a method named kinetic energy that accepts an object mass in kilograms and velocity in meters per second as argument. We know it's going to accept arguments, mass, and velocity. So I'm going to define some parameters for this kinetic energy method. So the first parameter I'm going to define is mass. Now again, mass can be a double value. It can be, let's say, 50.2. So I'm going to define the mass parameter as a double. So double mass. And the next parameter I'm going to define is velocity. Now we know velocity can also be a double value, let's say 80.2. So I'm going to define that as also as a double value, and I'm going to call it velocity. Yes, I'm going to define it as velocity. And basically in this method, the user is going to pass in the mass and the velocity. We can use those values to basically calculate the kinetic energy. So basically this method is calculating the kinetic energy, and we've been given the formula here. So now let's declare a variable that we're just going to hold the kinetic energy, because we want to calculate the kinetic energy. So I'm going to define a double variable. Now the kinetic energy, like we said, can be over here. The kinetic energy, we said, can be a double value, like let's say 80.2. So I'm going to define a variable called, it's going to be a double, I'm going to call it kinetic energy. It doesn't matter if it's the same as the name of the method. It doesn't matter. This is a variable in the method we're going to use to store value and store stuff in there and return it. So double kinetic energy is going to be equal to, now you're just following this formula. So half, and I'm going to surround it with parentheses because I want half to evaluate to 0.5, right? Now there's one problem. If you try to, do I have my calculator open? Yes, I do. All right, so if you try to divide 1 by 2, right, you get 0.5. But this result is not going to give you 0.5 because Java sees this expression as an integer division, because both operands, the 1 and the 2, both operands are integers. Okay, anytime you do a division and both operands on the left and right are integers, Java is going to consider this expression as an integer division. So and what happens with integer divisions is, instead of this expression resulting to 0.5, it's going to result to 0. It's going to slash off anything after the decimal points and result in 0, because it's regarding this expression as an integer division. But we don't want that. We want it to give us 0.5. Otherwise, basically whatever we type here is going to be 0, because any number multiplied by 0 gives you 0. We don't want that. So the way we can keep this 1 over 2, but at the same time have it result in 0.5, is we have to, at least one of these operands has to be, like, it has to be a double. So you can just do 1.0. One of these operands has to be a double, or you can do 2.0. Okay, one of these. If both of them are doubles, that's fine. You can do 1.0 here, but divided by 2.0. You know, and all it needs is one of them. Only one of them has to be a double. Or you can just still keep them as integers, like 1 or 1 over 2, but you can apply typecasting. We can cast this value to a double. We can it's kind of like converting it to a double in a way. So we can typecast it. We can cast it to a double, and that's going to make, let's say, one of these a double at least. So to do that, to kind of convert 1 to a double or cast it to a double, that's the actual term, I'm going to put the word double surrounded with parentheses in front of one of these. In this case, I'm in front of 1, meaning 1 now is going to become 1.0, and Java is now going to consider this as not an integer division, but it's going to see this as 1.0 because at least one of these operands is double. It's going to now divide this properly and give us 0.5 as a result. Okay, so now we have the half of this formula part done. Now we are multiplying by the mass. We are multiplying that by the mass the user typed, which is this, or the user passed in to this method. It's going to be stored in this variable. So we're multiplying by mass. Oops. And we are multiplying by the velocity squared. So we are multiplying by the velocity squared. Now you can go ahead and put in parentheses and do, let's say, velocity. Now velocity is going to be stored in this variable. That's going to be the velocity that the user types. So now velocity squared is basically velocity times velocity, right? You can go ahead and just do velocity here times velocity, and this is going to work. Okay, or you can also use the math library and basically call the math class. It's pretty much the same thing. So math, we can just call math.pal method, and pal is basically takes two arguments. The first argument raised to the power of the second argument. So it's velocity squared, right? So I know velocity squared. So math.pal takes in, so this is a math class. I'm using one of the methods in the math class called pal. And power is basically power. It stands for power. It takes two arguments, and basically it computes the first argument, which is velocity, raised to the power of the second argument. So it's going to be velocity squared, and return the result. So you can do this, or you can just do velocity times velocity, which is the same thing. All right. But if you had something like velocity cubed, then you can type velocity times velocity times velocity, which is long. It's better to just use the math.power and just say velocity, 3, and then now it's going to be velocity raised to the power 3. The same thing if you had velocity raised to the power 4, you can just type in velocity and 4 using the math.power instead of typing velocity times velocity times velocity times velocity. So that's where the math.power comes very handy. Okay, so now this hopefully should give us the correct formula, or the correct result from the formula. All right, so now we'll have the kinetic energy basically with this. I need to terminate this. And once we have the kinetic energy, what we want to do is return it. So I'm going to go ahead and return the kinetic energy here. I'm going to return the kinetic energy so that we can basically use the value that's being returned. So now in main, the program wants us to, it says demonstrate the method by calling it in a program that asks the user to enter values for mass and velocity. So we know that we are going to be asking for user input. We know that we're going to ask for user input. So that means we need to use one of Java's features for accepting user input. So we have a couple of options. We have the JOption pane or the scanner class. Now for this one, let's see. I'm going to use the scanner class. I'm just choosing to use the scanner class. We can use the JOption pane. I'm just choosing to use the scanner class. So to use the scanner class, we need to import it by typing import java.util.scanner. So now we have access to the scanner class, and now we can go ahead and use it in main. So what I'm going to do is, once we have the scanner class, we need to go ahead and create a scanner object so we can use it to accept input from the user, and basically do some conversions with it. So I'm going to create a scanner object. I'm going to call it scanner. I am creating a new scanner object in memory. I'm passing in the system.in method, which is basically going to accept byte info from the keyboard and connect it to the scanner object that we just created. We can then go ahead and use the methods in the scanner class to convert whatever the user has typed to, let's say, doubles or integers or whatever we want them to be in. So now what we want to do is we want to ask the user to enter the mass and then the velocity, because those are the two arguments that are going to be passed into the method kinetic energy. So I'm going to ask the user to enter the mass and the velocity. So I'm going to basically display the message saying with the system.out.println and say, oops, sorry. Please enter the mass, just to keep it simple. And oops. Once we ask this user, sorry about that. Once we ask this user this question, we want to go ahead and call scanner.next double, and scanner.next double is basically going to pop up some kind of text box, and it's going to allow the user to type in something, and whatever the user types is going to be converted to a double and returned. Now double, because like we said, mass can be a double. Okay, so I defined it as a double parameter over here. So mass can be a double. It can be, let's say, 50.2 or 50.8. So that's why we define it as a double, and that's why we are converting whatever the user has typed to a double and returning it into a variable that we haven't declared yet. So once that value is being returned, we need a place to store it. So I'm going to go up in main over here, which is here, main here, and declare a variable which is going to hold the mass, the user's mass. So I'm going to declare a double variable, and I'm going to call it user mass. It's just going to be a variable that's going to it's going to store the mass that the user types. So user mass over here now is going to be equal to whatever the user typed converted to a double and returned. Okay. Now we're going to do the same thing for velocity, because we need the velocity also to pass into this method. So I'm going to paste this method, change the label to please enter the velocity. And we're going to declare a variable. Okay, so it's going to pop up some kind of text box. It's going to allow the user to type in the velocity. It's going to convert the velocity into a double and return it. And when it returns it, we need a place to store it. So I'm going to define a double variable, because we said velocity can also be a double, let's say 2.2. That's why we define it as a double over here. And I'm going to create a variable called user velocity, and I'm defining it as a double. So user velocity now is going to hold the velocity that the user typed, which has been converted to a double and returned. So now we'll have the two values, user mass and user velocity. And once we're done, now we can go ahead and call the method, use these two values to calculate the kinetic energy and print it out, right? I think it wants us to print it. So it says demonstrate the method by calling it in a program that asks the user to enter the values for mass and velocity. Yeah, I guess it wants us to print it. So now I'm going to go ahead and call kinetic energy, and I can pass in the two values, which is user mass, because kinetic energy takes in two arguments. It takes in the mass and the velocity. We have the mass that the user has typed and the velocity that the user has typed. We can use those values in place of the arguments here, in place of the arguments that this method needs. So it's going to be kinetic energy, user mass, and user velocity, like this. And basically we know that this method here is going to return a value, which is it's going to return the kinetic energy. So we need a place to store that. We need a place to store that as well. So I'm going to define a variable. It's going to be a double, because we said double. We said that the kinetic energy can be a double. Let's say 2.5, or it can be a decimal. So I define it as a double. So I'm going to define it as kinetic energy. Okay, these names that do not, they do not matter. This kinetic energy is local to main, and this kinetic energy is local to kinetic energy, the kinetic energy method. So these names, it doesn't matter that they're the same. This is just the name of the method. This is a variable in the kinetic energy. It doesn't affect it. This is a kinetic energy variable in the main, so they don't really see each other. If you want to be safe, you can go ahead and name them differently, but it doesn't affect it. Okay, so now kinetic energy, this variable is now going to store the kinetic energy that's returned from this method call. So now kinetic energy is going to store the results of that. And now we can go ahead and print out the result of kinetic energy. So system.out.println. We want to go ahead and print ln. We can say, we can even use the values stored in user mass and user velocity in the print statement, and say that we can say the kinetic energy so I'm going to say the kinetic energy with mass. I'm going to say user mass, because we know we have the value stored in user mass, so I'm concatenating it with the value user mass. Now we know user mass has a unit of, I think, kilograms. Yeah, so kilograms. So we can say the kinetic energy with mass this kilograms. Now actually let's go ahead and format it, because these values can be, can have a lot of decimal places. So let's go ahead and use the system.out.printf instead of the system.out.println. So we want to go ahead and format it. So system.out.print formatted, right? We want to format the string, and then and specify some format specifiers, right? In which some values are going to replace. So let's put a comma here for now, and let's create the string. So the kinetic energy with mass. Now we know this value that we're about to define a variable. The content of a variable is, is going to basically replace this. So I'm going to specify a format, right? So the kinetic energy with mass, I'm going to type in percentage F, because whatever value is going to replace this is going to be the user mass. User mass is a float, so I've specified it as a float. I've specified that I want to format a float by typing percentage F. Now I want to go ahead and specify a precision, which is going to be how many decimal places. I'm going to type in 0.2 in between the percentage and the F. So 0.2 is a precision, which means round this or format this to 2 decimal places. If you wanted 3 decimal places, you do 0.3, but I want to format it to 2 decimal places, so I'm going to do 0.2. And that's it, right? So the value is going to replace it, and the value that's going to replace this percentage 0.2F is user mass. So the kinetic energy with mass, so this value is going to replace it. Now let's continue the string. And velocity, I'm going to specify another format. So percentage 0.2F is pretty much the same thing, because now the value that's going to replace this format specify is user velocity. And user velocity is a float, so that's why I specified it as a float by typing percentage F. And I want to round it to 2 decimal places. And so the value that is going to replace velocity is going to be user velocity here. Yes, and we're not done yet. We want to finish the string. So the kinetic energy with mass 0.2 and velocity. Okay, so we can say S. Now we're going to specify another format, another format. So percentage F, and the value that's going to replace this is going to be the kinetic energy. Okay, the value that's going to replace it is the kinetic energy. So the first one is user mass, second one is user velocity, the third one is going to be kinetic energy. So we wanted to also round it to, and the kinetic energy, we said that also can be a float, like let's say 50.5. So we also wanted formatted as a float by we are typing percentage F for that, and we are rounding it to 2 decimal places by typing 0.2 in between the percentage and the F. And the value that's going to replace that is going to be kinetic energy. Now we are going off the screen, so I'm going to break it somewhere here. Now the values over here, these arguments, these variables are going to replace these format specifiers respectively. So the first one is going to replace, user mass is going to replace the first format specifier. The second argument, which is user velocity, is going to replace the second format specifier. The third argument, which is kinetic energy, is going to replace the third format specifier. And then now we're done. So let's compile this and see what happens. So I'm going to go ahead and save it where I normally save everything. Okay, so I'm going to create a new folder called kinetic energy. And I didn't mean to do that. I normally like to, okay, it's fine, I'll change it later on. All right, so kinetic energy .java is going to be saved in this folder, and it compiled without error, so that's good. So let's run it and see what happens. So please enter the mass. I'm going to enter, let's say, let's see, kinetic energy with mass kilograms. I forgot to type the unit, and velocity this, and you want to also go ahead and type the unit for velocity, I think in meters per second. Meters per second. I don't know what units to use for kinetic energy. I forgot. I don't know. All right. Okay, so now let's compile this again and then run it. You can put the units for kinetic energy if you know it. All right, so mass, I'm going to type in, let's say, 50. And the velocity, I'm going to type in, let's say, I don't know, just using random numbers here, 49. I'm going to hit enter. Now it says the kinetic energy with mass 50 kilograms and velocity 49 meters per second is 60,025 something. Okay, that's going to be the units for velocity. So we know, I don't have any way to confirm these numbers. I mean, I can go and check online or inline or stuff like that. But if as long as the formula is correct, they give us a formula here, half mv squared, then we're fine. So now we have a formula, we have a program that basically calculates the kinetic energy. Okay, if you have any questions, please comment down below and I'll do everything to respond to them. Thank you very much for watching. take care of yourselves, and I'll see you next time with the next program. All right, bye-bye.